Section 4.5, triangle congruence, and you have ASA, AAS, and HL. That stand for something. We'll go over that in just a little bit. This is the objective. Prove triangles are congruent by using the three that I just read. Now, it's important to understand that these are shortcuts to show that two triangles are congruent. Okay, and these are the three shortcuts that you're going to be able to use from now on. We have the vocabulary, which is just included side, and we'll define it on the next slide. Let me read this. An included side is a common side, which is this side. This is the common side of two consecutive angles in a polygon. These are the two consecutive angles. So again, this is the included side. Read this, explains that. This is the theorem that goes with included side. So this is the first shortcut you can use to show that two triangles are congruent on section 4.5. I'll read this. If two angles in the included side of one triangle are congruent to two angles in the included side of another triangle, then the triangles are congruent. Notice that you have angle congruent, angle D congruent to angle A, angle F congruent to angle C, and the included side is congruent for both. So that's why we can conclude that these two triangles are congruent. Again, so this is the first shortcut that you can use to show that triangles are congruent on section 4.5, which is angle side angle. Next slide. Let's practice using angle side angle. This is determined if you can use angle side angle to prove that, the triangles are congruent. So you're looking at this angle being congruent to this angle congruent to this angle, and notice that this side is congruent to itself, reflexive property. So can you use angle side angle to show that these triangles are congruent? The answer is yes. Why? Because this angle here is congruent. Why? Because of the third angle theorem. So this is why this is a yes. For number 2, same directions, different picture. Now you're looking at these two triangles, NKL and LMN. Can you use angle side angle to show that these two triangles are congruent? Well, let's see. Given that you have parallel lines, and this is your transversal, you know that these two angles are congruent, alternate interior angles. And this is the short side that they share. So by reflexive, you know that NL is congruent to L, and this angle is congruent to this angle. Again, by alternate interior angles. This is all the information that we can gather from the picture. Can you say anything about this angle here being congruent to this angle? The answer is no. Why? Because you're not given that these two lines are parallel. If they were parallel, then you can say that this angle, let me put it in white. Excuse me. Here it is. Oh, I had this. Give me a second here. Technical difficulties, but anyway. White. So if these lines were parallel, then you can say that this angle is congruent to this angle. But you're not given that. So that's why, in this case, there's not enough information for us to determine that these two triangles are congruent by angle side angle. Okay? Next slide. Next shortcut or theorem is called angle side congruence. Theorem 4.5.2. I'll read it to you. It says if two angles and a non-included, no, this is non-included instead of included. So look at this picture. These are two angles. This is the side that is congruent, which is the non-included side. I'll start again. If two angles and a non-included side of one triangle are congruent to the corresponding angles and the non-included side of another triangle, then the triangles are congruent. So this is the picture, and this is what we can conclude. And again, this is another shortcut that we can use. First one we saw was angle side angle. Second one is angle side. Next slide. Here we go. It says use angle side to prove that the triangles are congruent. This is the given information. JL bisects KLM, and angle K is congruent to M, and this is what we want to prove, that this triangle on the top is congruent to this triangle. What we're going to do is we're going to prove this using a flow chart proof, which is very different than a two-column proof. And this is basically how a flow chart proof works. We write the given information. JL bisects KLM, and is given. So right below we write that it was given. And this is what this gives us. KLM. So then you know that this angle is congruent to this angle. And that's basically what we can generate from this statement, that KLJ is congruent to MLJ. Why? By definition of angle bisector. Okay. This produced the following. This is the statement, and notice that right below, this is what would normally be the reason in a two-column proof. Next, you're given that angle K is congruent to angle M, and notice that it's already highlighted, and this is what goes right below, given. Next, we have that JL is congruent to JL. Why? What's the reason? Because it's reflexive property. Now, this is what happens next. At this point, you're going to put all these three together, and this is where you're able to generate from these three statements. You can say that triangle JKL congruent to triangle JML, which is what you're trying to prove. What's the reason? Angle side. We just shown that angle side is congruent to angle side. And notice that this is a non-included side. So this is how you prove by using a flow chart proof. Moving on to number 5. Again, it says use angle side to prove the triangles are congruent, given that angle X and angle V are right angles, and you have parallel lines there, which you can read. And this is what you're trying to prove. The triangle YXW is congruent to triangle WBY. So this is what we're going to do, is we're going to use a flowchart proof idea again. This is given. From here, we can write the second information that was given. From here, we're going to generate something. Now we're going to be going to the right. This allows me to say the following, that angle YWX is congruent to angle WBY. The reason for that, because of right angle theorem. All right angles are congruent. Then, from here, I'm able to generate that this angle YWV is congruent to WYX. And then from here, and we know that this is by alternate interangles theorem. Next, at this point, this was not given, but I should be able to come up with this. I know that YW is congruent to YW, and this is by the reflexive property of congruence. And notice what you have. You have two triangles, angle side, congruent. So all these three statements give me the following. The reason for this is angle side. Moving on to number 5. This is another shortcut, theorem 453. This is what we call a HL. This is what we call HL, and it stands for hypotenuse leg. It reads as follows: if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So if you look at the picture, this is what you have. You have two right triangles. The hypotenuse is congruent. In addition to that, also a leg. The theorem tells us that we can conclude that these two triangles must be congruent. Next slide. So let's apply this. It says determine if you can use HL congruence theorem to prove that triangles are congruent. Number 5. Notice that you have a right angle here, and you can also come up with this is also a right angle because they form a linear pair, and by reflexive property you have this. So do we have enough information to show that these two triangles are congruent by HL? And the answer is yes, because we have the hypotenuse congruent and a leg congruent in two right triangles. 6. This is the given information for number 6. You have that this is congruent to that. You have two right angles. Is there enough information to show that these two triangles are congruent by HL? And the answer is no. Why? Because you're not given any information about the hypotenuse, so that's why you cannot assume that these two triangles are congruent by HL. You cannot assume that the hypotenuse is congruent, so there's not enough information to show that they're congruent by HL. 7. HL. Notice that we have two right triangles. The hypotenuse is congruent. Both hypotenuses are congruent to each other, and then the reflexive property. So do you have a hypotenuse and a leg congruent? And the answer is yes. So 5 was a yes, 6 is a no, 7 is also a yes. And if you want me to clarify any of these 3, talk to me in class. It says identify the positive order theorem that proves that triangles are congruent. So in this case, you need to determine which shortcut you can use to show that these triangles are congruent. So if you look at the given information on number 8, you have that this angle is congruent to this angle is congruent to this angle. So are these two triangles congruent? The answer is yes. By what? By angle, side, angle. Angle, side, angle, angle, side, angle. And notice that this is the included side that you saw earlier. Number 9, you have this side congruent to this side. This angle here is 90 degrees, which means that these two sides are, these two angles, or these are perpendicular. You have this side congruent to this side. Notice that you have two right triangles. Do we have a hypotenuse and a leg congruent in both? And the answer is yes, so that's why we can use HL. Number 10. So notice what you're given. This side is congruent to this side. This side is congruent to this side. And this angle outside here is congruent to this angle here. But you know that these two angles are vertical angles. So that's why this is congruent to this angle. In addition to that, same thing here. So do I have enough information to show that these two triangles are congruent? And the answer is yes. And actually you can use 2 shortcuts. The first one is side, angle, side, or side, side, side. Because of the reflexive property, this side is congruent to itself. And this is what you saw in section 4.4. And this is the end of section 4.5 video.